And this we are going to see about how we can able to have the Remix IDE environment. The topics we are going to see is what is Remix IDE, the features of Remix IDE, main components of Remix IDE, and the steps to use Remix IDE. So Remix IDE is nothing but it is an integrated development environment, the web-based tool used to write, compile, deploy, test, and debug the Ethereum and smart contracts written in the Solidity. So it is one of the most popular IDEs for the beginners and the developers learning blockchain programming since it runs directly in a web browser. So this requires no installation is required for having this particular environment. The features of Remix IDE is you can able to write the Solidity smart contracts, compile the smart contract, and check for the errors. Say deploy the smart contracts to a local blockchain or a Ethereum test and networks. Test and debug the smart contracts. You can able to interact with the deployed contracts through a user-friendly interface. So this supports your plugins for testing, static analysis, and deployment. We have the main components of a Remix IDE, which is nothing but a file explorer, create and manage the Solidity files, the Solidity compiler, which compiles the smart contract. We have the deploy and run transactions that enables the deploys and executes the contracts. We have the debugger in handling the or identifying and fixing the errors, and we have the terminal or the console. So this terminal console displays the transaction details and the logs. The steps which you are going to use for the Remix IDE is going to have the open. We are supposed to have this particular link. So this particular link will move on to the online platform, IDE platform, where you can able to have your own user-based applications to be run. So you can able to create a new .sol file. So SOL file is nothing but the Solidity file. So write the Solidity smart contract. So once you have been written the Solidity smart contract, you can able to compile it. So compile the contract using Solidity compiler. We can able to deploy the contract using deploy and run transactions. Test the contract by calling its functions. So this is the steps which will be following it to have the code to be deployed in the IDE platform. So the advantages of using this Remix IDE is going to be free and browser based. So no software installation is required, which is going to be beginner friendly interface that supports smart contract debugging and testing part. So this integrates with MetaMask and Ethereum test networks too, the predefined libraries. So the example workflow, we're just going to have a short demo on this. Like we are going to write a Solidity contract, that is your product tracking Solidity file, and we are going to compile the contract. We are just going to deploy it using the JavaScript virtual machine or the MetaMask. So deploying it, and we can able to add a product using the add product function. We can able to update its location with update location. We can able to view the product details using the get product. So this gives an overall view of a supply chain environment. So in a supply chain environment, we will be having this product tracking where we emphasize on adding the product and viewing the product and getting the product information details. So the applications where we can able to use this Remix IDE is going to have a smart contract development. We can able to create our own smart contract informations, and we have blockchain learning and education purpose, and we have supply chain management, healthcare applications, voting systems, and we can able to have it applied in the decentralized applications too. So as a summary, we are going to look about the Remix IDE, which is a browser-based deployment environment used to create, compile, deploy, test, and debug Solidity smart contracts on the Ethereum blockchain environment. Thank you. Now we are going to see how we are going to work on with the Remix platform environment. So clicking on to this remixethereum.org.lab, we're just going to have this particular environment to which we are just going to take up this start coding part. So we have the file explorer. Okay, in this file explorer, we have the information related to what are the files we are just going to work on with. So we normally go in with the contracts. In the contracts, we will be saving all those information. Okay, and after this, we have the Solidity compiler to compile this. Once the compilation has been successful, I can able to go in with the deploy and the run transactions. So we can able to go with the start coding part. So in a start coding part, so this is a sample which has been given for having a hello world to be taken as a small message given to the contract information. Here, we are just going to create a new file named to be product tracking dot, saving it as SOL, the Solidity file. And in this, we are just going to create it. Creating a new file with ms product tracking dot SOL. Have created it, and this is the place where we are going to have the file. And we have few lines of Solidity files to have the code to be evolved. So here is the lines of code to which we have been emphasis on. So here is the Solidity file of product tracking. We have the information related to the product, that is product ID, product name, manufacturer, current location, and delivery. And we have the mapping of each and every product that will be mapped to its product ID. So making it as publicly visible. And we have the add product function. Like whenever a new product is coming into existence, we are supposed to define the product ID, product name, manufacturer, their location. So this is going to be making us a public. So this defines your infinite class, which means that there is no computation. We are just going to get the information, okay, uh, and recording it. Okay, so this is going to me, and based on the local system, we are just going to have the information to be taken up, and those product informations that has been taken up has been recorded to its product ID. So initially we have been make mark delivered to be false. So this is going to be similar to a constructor. So we are just going to have all this product information mapped to the class information. And here comes the second functionality, that is your update location. So if there is any change in the product that has been made to your logistic perspective, there comes your product location change, updation in the location change. So giving the product ID, you're supposed to have the product ID information and the new location where it has been designated to have to be taken as an input from the user perspective. So once you're going to have this, we are supposed to update the particular new location to its current location. So updating the information will be recorded to its product log. The next functionality, third functionality, is going to be mark delivered. So once the unit has been reached, you can able to make it as a true. So you are supposed to have that product ID. On getting the product ID, you can able to make that particular detail to be enabled to be true. So getting the information of product details, we are going to make use of the get product, passing the product ID. When passed the product ID, we are just going to view all this information. Like we are supposed to view the product ID, product name. We can able to have the manufacturer, then the location. The last one is going to be marked delivered. If it is marked delivered as false, which means that it doesn't reach, the product doesn't reach the customer. If it is going to be true, which means that the product has been reached to the customer side. So this is the product identification which has been mentioned it. So on each and every function call, this particular information will be written up to its memory location. So this is the lines of code that has been started with a sample information. So this, we are going to make it to the Solidity compiler. We are going to run to it. Okay. So when you're going to have this, we are going to compile product tracking.sol. Okay. So this information is states that the compilation is successful. So once the compilation is successful, we can able to go and deploy and run the transactions. So we are choosing the deploy and run transactions. So in your deploy and run transactions, we find the product tracking. So in this product tracking, we have the value 0. Gas limit is going to be auto. Okay. And we have few of the functions that are evolved to it. So few functions that are evolved to it are, so here we are going to make use of the CANCOM, the platform environment. Okay. And we are supposed to have the functions to be evolved to it. So we have the account. Name the account 1. So we are supposed to have the informations of the functions that we are going to have it. So in your deploy, we have been chosen the platform is to be Remix VM Canum. Here we have been compiled it. Okay. And we are going to deploy it. Okay. Once we have been deployed it, we'll be seeing few functions later to it. Okay. So the functions are, can able to select the functions. So here we can able to come up with the functions like add product, mark delivered, update location, get product and products. So when we are going for the first option, like add product, we are supposed to give the information to it. So like we're supposed to create a new product ID with product name and the manufacturer, Nova, and it is going to be Mumbai. Location. So once I have been given all those informations, I can go have the transaction to be enabled. So this is going to be the console or the terminal where you can able to identify what is the information related to it. We have been generated a hash value, okay, to that particular function of add function. Okay. So these are the details. This is the log information pertaining to the transaction that evolved to it. So similarly, the other function is going to be, so once I have been done with the add product, we can go in for look for the get product details. Like, so get product, I'm just going to cope up with 101, making call function. So 101 is going to be the product ID. We have the laptop, Lenovo, Mumbai, and we have the mark delivered as false. Okay. So when you are moving to the next one, mark delivered. So we are going to have the mark delivered for that particular code to be 101. For this particular, we are going to make it enabled as true, which means that the product has been delivered to the customer side. So we are enabling the transact. So the transaction has been successful to it. Okay. So now when we are going to get the information about the product log, so we are supposed to once again compile the process and make the deploying nature. In a deploying nature, we can able to go in and test with the functions of get a product of this particular code and call for it. So now it turns up to true, which means that the concerned product has been delivered to it. Similarly, we can able to test up with the update location too. So for update location, so 101, we can able to have the new location to be Chennai and make it as a transact. So can able to check whether the location has been updated or not. using the get product, call the particular transaction to be enabled. So it has been updated to, the location has been updated to Chen. So here in this, we have been seen few example how we can able to work out with a remix platform. So in a remix platform, we have been just made a supply chain management application that has been incorporated, and we have been seen few outcomes of it. Thank you.